स्मार्ट माइंड्स ट्यूटोरियल सफलता का आपका प्रवेश द्वार।
So find the eigenvalues and eigenvectors of A is equal to 4 minus 1 6 2 1 6 2 minus 1 8. So first let us write the given matrix. Given A is equal to 4 minus 1 6 2 1 6 2 minus 1 8. Now to find the eigenvalues, we need to take the characteristic equation. So the characteristic equation is determinant of A minus lambda I is equal to 0. So what is A minus lambda I? First let us write A matrix. 4 minus 1 6 2 1 6 2 minus 1 8 minus lambda I, lambda 0 0 0 lambda 0 0 0 lambda is equal to 0. That is, now subtract this. 4 minus lambda minus 1 6 2 1 minus lambda 6 2 minus 1 8 minus lambda is equal to 0. Now we need to expand the determinant. Here don't forget to put this determinant. So we need to find out the determinant of this matrix. So if you find the determinant, you will get 4 minus lambda into 1 minus lambda into 8 minus lambda minus 1 into 6. Now minus of minus 1 will become plus 1 into 2 into 8 minus lambda minus 2 into 6 plus 6 into 2 into minus 1 minus 2 into 1 minus lambda is equal to 0. Now we need to expand this. So 4 minus lambda into 8 minus lambda minus 8 lambda plus lambda square plus 6 plus 16 minus 2 lambda minus 12 plus 6 into minus 2 plus 2 lambda is equal to 0. So that is 4 minus lambda into lambda square minus 9 lambda plus 14 plus 16 minus 12 is 4 minus 2 lambda plus 6 into minus 4 plus 2 lambda is equal to 0. Now open the brackets. 4 lambda square minus 36 lambda plus 56 minus lambda cube plus 9 lambda square minus 14 lambda plus 4 minus 2 lambda minus 24 plus 12 lambda is equal to 0. Now minus lambda 3 we will write first. Then 4 lambda square plus 9 lambda square is 13 lambda square. Now we need to solve the lambda terms. Minus 36 lambda minus 14 is minus 50. Then this is minus 52. Minus 52 plus 12 is minus 40. Minus 40 lambda plus 36 is equal to 0. Now we take minus common. So lambda cube minus 13 lambda plus 40 lambda minus 36. Now this is a cubic equation. So one root you can get by trial and error method. So if I substitute 1, anyhow it is not becoming 0. So let us try with lambda is equal to 2. So if lambda is equal to 2, then 8 minus 26 plus 80 minus 36. That is 1 minute. This is lambda square. So if I put lambda is equal to 2, this will become 4, no? 2 square is 4 and 4 into 13 is 52. So minus 52 plus 80 minus 36. That is 88 minus 88 is 0. What does it mean? Therefore, lambda is equal to 2 is a root. So you got one root. Now the remaining roots we will find by synthetic division. So 1 minus 13, 40 minus 36. And as 2 is a root, we take 2 over here. First you take a 0. 1 plus 0 is 1. 1 into 2 is 2. Then minus 11. So minus 22. And this is 18. 36. So minus 36 plus 36 is 0. So this is lambda square minus 11 lambda plus 18 is equal to 0. Now here we need to factorize. Minus 9 lambda minus 2 lambda plus 18 is 0. Lambda common, lambda minus 9 minus 2 common, lambda minus 9 is 0. So lambda minus 9 into lambda minus 2 is 0. So that is lambda is equal to 2 and 9. So finally we can conclude, therefore eigenvalues are 2, 2, 9. Now let us find out eigenvectors. So if lambda is equal to 2, what is a minus 2i? Or what is a minus lambda I? 4 minus 1, 6, 2, 1, 6, 2 minus 1, 8, minus 2, 0, 0, 0, 2, 0, 0, 0, 2. So that is 4 minus 2 is 2, minus 1, 6, 2, minus 1, 6, 2 minus 1, 6. Now let us see what is the augmented matrix. The augmented matrix, that is A minus 2i and O, is 2 minus 1, 6, 0, 2 minus 1, 6, 0, 2 minus 1, 6, 0. Now as you can see, all the three rows are equal. So we can make any two rows as completely zeros. So R2 is R2 minus R1. R3 is R3 minus R2. So that is 2 minus 1, 6, 0, 0, 0, 0, 0, 0, 0, 0, 0. So what are the equations? The equations are 2x1 minus x2 plus 6x3 is equal to 0. So 2x1 is equal to x2 minus 6x3, or x1 is equal to x2 by 2 minus 3x3. And over here you can see x1, x2 and x3 are free variables. X2 and x3 are free variables. So what is the general solution? So the general solution is x is equal to x1, x2, x3. That is equal to 1 by 2 x2 minus 3 x3. This is the value of x1, and x2 and x3 are free variables. So we will write as it is. Now let us separate x2 and x3. So 1 by 2, 1, 0 into x2 plus minus 3, 0, 1 into x3. So that is, if you take the LCM, you will get 1, 2, 0. If I multiply each element with 2, we will get 1, 2, 0, x2 plus minus 3, 0, 1, x3. So these are the eigenvectors. So the eigenvectors corresponding to lambda is equal to 2r. Let us denote it by v1 and v2. 1, 2, 0 and v2 is minus 3, 0, 1. These are the eigenvectors corresponding to lambda is equal to 2. Now, if 11 is equal to 9, then we need to find out the eigenvectors. So, consider A minus lambda I. What is A minus lambda I when lambda is equal to 9? 4 minus 1, 6. 2, 1, 6. 2 minus 1, 8. Minus 9, 0, 0. 0, 9, 0. 0, 0, 9. So that is 4 minus 9 is minus 5, minus 1, 6. 2 minus 8, 6. 2 minus 1, 8 minus 9 is minus 1. Now, we need to take augmented matrix. What is augmented matrix? A minus 9i and then O. What is that? Minus 5, minus 1, 6, 0. 2 minus 8, 6, 0. 2 minus 1, minus 1, 0. Now we need to do row transformations to make them 0. Let us make this element 0. So what should we do here? R3 is R3 minus R2. Let us do first. So first and second row is the same. Minus 5, minus 1, 6, 0. 2 minus 8, 6, 0. Then 0, 7, minus 7, 0. Then what is R3? R3 is R3 by 7 and R2 is R2 by 2. So that is first row we are not changing. Second row let us divide by 2. 1 minus 4, 3, 0. And third row let us divide by 7. 0, 1, minus 1, 0. Now I want to make this element as 1. So I will divide R1 by minus 5. So that is 1. Before doing that, let us do one more thing. Some other transformation I will take here. R1 I will take R1 plus R3 first. So you will get minus 5, 0, 5, 0. Now first row both the elements are 5. So when you divide you will not get any fraction. That is the main reason for doing this. Now you can take R1 is R1 by minus 5. So you will get 1, 0, minus 1, 0. Then 1 minus 4, 3, 0. 0, 1, minus 1, 0. Got it? Now we will do R2 is R2 minus R1 because I want to make this 0. So first row we are not changing. Second row R2 minus R1. 1 minus 1 is 0. Minus 4, 4, 0. Third row also we are not disturbing. Now in the second row you can see there are two 4s. So we can divide it by minus 4. So R2 is R2 by minus 4. So you will get 1, 0, minus 1, 0. 0, 1, minus 1, 0. 0, 1, minus 1, 0. Now you can see last two rows are same. So we can make any one row as completely zeros. So R3 is R3 minus R2. So you will get 1, 0, minus 1, 0, 0, 1, minus 1, 0, 0, 0, 0, 0. Now once you convert this into echelon form, we will write the equations. What are the equations? X1 minus x3 is equal to 0. From this we can write x1 is equal to x3. Now from the second row, x2 minus x3 is 0. So we can write x2 is equal to x3. Now because x1 and x2 both are in terms of x3, so we can take x3 is a free variable. Now what is the general solution? How can we write the general solution? X is equal to x1, x2, x3. Now x1 is equal to x3, right? So we will write x3, x3, x3. If you take x3 common, you will get 1, 1, 1 into x3. So what is the eigenvector? So eigenvector corresponding to lambda is equal to 9 is 1, 1, 1. Got it?